Hello, everyone. Thank you for joining us today. My name is Divya Khare, and I am your host for this session. So, starting up, Industry 4.0 is the new revolution in the timeline of manufacturing. Factories designed at the beginning of the Industrial Revolution relied heavily on human efforts, which introduced a lot of errors. To minimize the impact, manufacturers incorporated new automated technologies. Although complete autonomous factories are yet to arrive, humans and robots have already started working together to overcome today's challenges. Enterprises have grown to become corporate giants through collecting and analyzing data. A lot of industries have access to data but fail to harness this data to their advantage. Industry 4.0 is the current trend of automation and data exchange in manufacturing technologies. It includes cyber physical systems, the Internet of Things, and cloud computing. Industry 4.0 creates what has been called a smart factory. The pandemic has hit the manufacturing segment in unprecedented ways. Smart analytics driving smart manufacturing is the key to accelerate solutions. Now, to understand how to achieve this using the relevant technology is going to be the key pointer for the discussion. So, let me welcome the key speakers for today. From Google Cloud, we have Ms. Manisha Sharma Kohli. She is the head of customer engineering for Google Cloud Partners in India and South Asia. In this role, she drives the development of Google Cloud Partner ecosystem through technology adoption and enablement, joint go-to-market initiatives, and successful deployment of digital transformations, solutions across industries. Welcome, Manisha. I'll let you take this forward and help us understand the technology perspective of smart analytics and its approach towards smart manufacturing.
Thanks a lot, Divya. And good morning, good afternoon, and good evening to all of you. Hi, I am Manisha Sharma Kohli, and I lead the mission of developing and nurturing our partner ecosystem for Google Cloud in India. As an industry with a lot of history, this isn't the first time manufacturing has experienced disruptive changes. The COVID 19 pandemic impacts the industry both short term and long term. And we see technology helping the industry respond, recover, and reimagine just as it has done in the past. The previous adversities like World War II, 9/11 attacks, and the 2008 financial crisis have shown us that while some of these effects may be temporary, these global challenges have really accelerated the emerging trends and brought about some lasting changes to the industry. But the question remains, what lasting changes should we expect coming out of current disruption? We're already seeing acceleration in many forms across our society during this shut in economy. There is social distancing, heightened focus on cleanliness, reliance on food delivery, growth in e commerce and specifically online grocery shopping, and so on and so forth. But how will all this translate to manufacturing and how will the industry pivot to meet the need? There are a couple of trends that we at Google are observing globally that will drive the new normal. The immediate change most of us are currently going through is increased health and safety requirements. This can come in the form of enforced distancing, through smart technologies and shop floor and factory reconfigurations. Remote work has become a default for many jobs. Particularly in manufacturing, we are seeing a dramatic uptake of our virtual collaboration tools, including companies that are using these technologies for the first time at scale. However, we believe that the deeper, more profound changes are yet to come. While the past decades have been characterized by manufacturing moving more and more to lower cost locations, we believe we'll see a reversal of that trend. The shift to higher cost locations will lead to acceleration of automation and digitalization. This shift will be needed to prevent overall manufacturing costs from increasing. These geographic shifts will also lead to a fundamental restructuring of supply chains to enable more diversification and localization. In consideration of the legacy rich nature of manufacturing industry as well as the market challenges brought about by pandemic like COVID-19, there are three main areas where we at Google Cloud can help manufacturers. Number one, maintaining business continuity. This is still top of the mind for many of our customers, and we expect that we will continue to see increased volatility in the external environment. Number two, operations optimization. We are helping customers achieve the next level of efficiency using digital tools. And number three, openness and integration across OT and IT environments. We understand that all manufacturing companies have a long, rich history, and hence they face decentralized decision making, siloed data, multifaceted strategies, and complex local politics. We totally understand the complexity of the existing systems, and we want to embrace the desire of our customers to keep their mission critical data and systems on their company premises. Additionally, we also have supported OPCUA, which is Open Platform Communications Unified Architecture Protocol, a machine to machine communication protocol for industrial automation, through which we can utilize factory machine data, and we can bring that data in Google Cloud to facilitate advanced manufacturing insights as well as control and monitor production processes. Let us delve a bit deeper into the solutions that can help manufacturers navigate these three focus areas. Worker safety compliance and remote working has led to manufacturers thinking about employing productivity tools to help workers reduce their machine interaction and maintain physical distance from each other. Our solutions under Google Workspace portfolio have enabled our customers to improve company wide collaboration through video conferencing. Customers have strengthened their quality procedures via Google Forms, Docs, Sheets, Slides, and some of them have reduced email usage by up to 90%. Visual inspection for factory environments is another use case that we are coming across. And this enables the plant managers to monitor factory floor worker safety via cameras and artificial intelligence. Visual inspection can monitor the use of essential protective gears like masks, goggles, distance compliance from each other in an enclosed environment, and proximity to machinery or hazardous sites. Touchless interaction for machines is another very interesting area which customers are talking about. Powered by Google Dialogflow offering, it enables workers to control industrial machinery with their voices. By limiting the machine interaction and instead using voice commands to control the machinery, manufacturers can improve the worker productivity and reduce the spread of the viruses on digital interfaces. Manufacturers are also implementing industrial adaptive controls, such as intelligently controlling your HVAC equipment to minimize energy consumption in commercial buildings. It's a very simple solution where every 5 minutes, a cooling system sensor sends data to cloud-based solution. A deep neural network AI solution predicts future energy efficiency and temperature. The AI-based model selects the actions that satisfy the safety constraints and minimize future energy consumption. And finally, the recommended actions are sent to the building management system, which is further verified by the local system before implementation. Finally, logistics scheduling and routing uses Google AI and ML to predict how and when new pickups will come from, how the driver routes can be optimized using GIS and Google Maps integration. Manufacturers are looking at further optimizing their operations and their supply chains and logistics by combining this data with other data sources such as packing trucks, staff schedules to maximize their asset usage. One such customer who has recently implemented this solution with us is UPS, United Parcel Service. I think United Parcel Service started as a messenger company in 1907 and has steadily grown over 112 years to become the largest package delivery and specialized transportation service provider. Those of you who know UPS would know that they deliver on an average 21 million packages or parcels every day across 220 countries. On an average, their drivers make that happen by taking 120 stopovers, drop-offs and pickups, you know. So there are unthinkably large number of routes that the driver can take from stop number 1 to stop number 120. Working in collaboration with Google Cloud Platform, UPS was able to design an intelligent routing software that tells the delivery driver exactly where to go every step of the way. The routing software now saves the company up to $400 million a year and reduces the fuel consumption by 10 million gallons a year. Um, So one solution that we offer that can impact manufacturers' bottom line is manufacturing visual inspection for quality control. Today, the manufacturing of many products from cookies to windmills requires manual quality control processes or ones with very expensive automation. Visual inspection addresses this challenge by capturing the images of items on the production line and uses AI to detect defects across a range of product types. With visual inspection, manufacturers can improve the quality control processes, reduce the cost associated with manual inspection, and increase their throughput. What is special about our approach to visual inspection is that it's particularly easy to deploy and use. Setup is quick, and thanks to the pre trained models, the number of images required to train a model is reduced. It's also fully integrated with our larger AI stack, making it easy to scale across multiple adjacent use cases. Kyocera Corporation is a Japanese multinational ceramics and electronics manufacturer which has used this solution for their quality processes and defect detection. With this visual inspection tool or solution, they were not only able to detect the defects to the accuracy of 98.5%, but they were even able to detect the defects which they were not able to discover through the manual quality checks. Okay, so the first solution under the Smart Factory portfolio is the custom edge solutions, which includes our Edge Tensor Processing Unit and Cloud Edge Manager for machine learning. At Google, we have the benefit of having the AI research team and the hardware teams work hand in hand to deliver something truly novel with the Edge Tensor Processing Unit, which is several times faster than the GPUs and CPUs which are available. We believe that Edge TPU will enable any data collector to become intelligent device, opening a whole new class of user experience. To jumpstart development with Edge TPU, we have created a small system on module and we call it Coral. Coral is actually a small system module that combines a quad-core CPU, Wi-Fi, a secure element, and Google's Edge TPU in a compact form factor. This reduces the design and integration times, and the manufacturers can pretty much make any device and asset intelligent by introducing this small system module on top of that. It also gives the users the flexibility needed to fit into the custom design envelopes and applications. The second part of our smart factory solution is IoT Core, which is a hardware agnostic platform that can securely connect your existing network of devices, collect and store streaming data, and then manage the identities of those devices so they can consume other services on Google Cloud to power advanced and complex use cases. The third part of our smart factory solution is all about generating actionable insights from disparate sources of data, be it IoT sensor, your SAP functional systems, or your own business data. On that note, it's important to call out that more and more organizations today are moving their SAP workloads to Google Cloud due to the flexible deployment options, business friendly pricing, and reduced overall total cost of ownership. SAP themselves have recently hosted their development environment on GCP. This data, coming from different sources, when ingested and aggregated, can reveal great actionable insights about your business, which can be really game changing. One of our customers, Swiss Steel, which is Europe's leading supplier of engineering and free cutting steel, exactly did that. They wanted to build and scale solutions to help them succeed in an increasingly competitive market. Using Google Cloud's offerings like PubSub and Dataflow to BigQuery, Swiss Steel was able to build a secure and stable platform to link their processes and data to analyze trends across the business. By switching to Google Cloud offerings, Swiss Steel was able to reduce their cost by over €500,000, and they were able to build innovative solutions such as price prediction analytics and predictive maintenance to further improve their operations. Finally, adopting Industry 4.0 is a top tier priority. But let's face it, most large manufacturing companies in the world today are more than 85 years old. There are inconsistent technologies at different plants and factories. The organizations, therefore, must modernize and unify operational technology and central IT systems with the cloud to be able to deploy Industry 4.0 solutions. Anthos, Google's cloud's new open platform, is a solution for that. Anthos lets you build your application once and run it anywhere, simply, flexibly, and securely. Google Cloud's Anthos is the only 100% software based solution with no dependency on proprietary hardware. So you can quickly get up and running on your existing hardware with no stack refresh. Anthos also leverages open APIs, giving you the freedom to modernize at any place, anytime. Since it is based on Google's Kubernetes engine, our managed Kubernetes service, you automatically get the latest feature updates without really having to worry about the refresh for the Anthos platform. Finally, you might not immediately associate Google Cloud with the manufacturing industry, but we are proud to support a broad range of manufacturing companies on their digital transformation journey. And those companies range from small, highly specialized players to global conglomerates. So, why are these manufacturers choosing Google Cloud? It is because of the unique differentiators that Google Cloud brings to the table and our substantial investment to support this industry. In the last 12 months, our manufacturing headcount has increased in engineering, customer success, sales, and leadership by 4 times. Our revenue from industrial manufacturing, automation, and transportation has increased by 8 times. And we have around 12 prioritized industry solutions available out of the box for industrial, automotive, airlines, and logistics. So we are committed to the success of our customers in manufacturing, and that is where we partner with partners like Pluto 7, and we bring digital transformation solutions for our customers in this industry. With that, I will hand over to Divya to take us to the next session.
Thank you, Manisha. This was indeed an informative session for us. As you mentioned, that in this new normal, remote working culture has become a default for many organizations. So it is very important for us to understand how to carry forward with the automation process in this pandemic scenarios and having the organizations adapt to the new normal. So, without a further ado, I would like to introduce our next speaker for the session, Mr. Manju Devdas, CEO, Pluto 7, and a supply chain domain expert. With an overall experience of more than 20 years in retail and manufacturing predictive analytics, he has helped companies with business transformations and revolutionized the way people do business. Let us hear from him about his journey about implementing analytics for various organizations. Welcome, Manju.
Thank you, Divya. And thank you, Manisha, for the amazing walkthrough of Google's platform, technologies, and capabilities that are ready for the industry with any scale of data volume or the kind of transformation that customers are envisioning. In my experience, having engaged with 400 plus customers worldwide at various stages in the digital transformation, it's amazing to see how humans adapt to extraordinary situations. Like Manisha mentioned, there has been crisis in the past, and whenever the crisis has ended, the automation and transformation has been far significant than what would have otherwise happened. When we look at the current pandemic situation, which has not only disrupted the manufacturing plants functioning, but also the supply chain overall, it brings in the innovation that, in my opinion, has been far superior and even surpassing the World War scenarios, where the innovation was extraordinary, primarily because we have never imagined a world with stops for 45 days worldwide. That has not never happened. Now that not only exposed the weakness in some of our legacy systems or processes, but it gave us an opportunity to take a step back and think about a resilient supply chain. For a resilient supply chain and a smart manufacturing, it starts with insights into how your manufacturing and supply chain works. That's where we bring in smart manufacturing, smart analytics for manufacturing. Like Manisha mentioned, the Industry 4.0, as it transforms from stage to stage, we have now reached stage 4, wherein we are now talking about the physical systems, IoTs, IoT, IT working in harmony. Combine that with machine learning AI, helping with digital based decision making as digital twins, all of which connecting your data in a cloud environment. We at Pluto 7 specialize in and bring expertise not only in Google Cloud technology, but also combine that with the domain. As Manisha walked you through some of the amazing capabilities of Google Cloud, for us, technology is less of a concern because we know Google Cloud scales horizontally, vertically, for a variety of data that our customers carry. But what's more important is making sure that we understand your environment. We understand the constraints of your legacy environment, the connectivity issues, or even the people and management and the change management aspects. When you combine this, that's when the true transformation happens. At Pluto 7, we work with global enterprises. Some of them it span multiple countries, some of them are local, as well as some mid-market and omni-channel retailers. Many of them primarily rely on data to run their business. And when we serve these customers, we start with understanding the customer's journey first, or where they are in the maturity curve. What is their vision? What is their charter? Why do they want to transform? That's part of our business architecture. Then we frame those into problems that fall under the smart analytics, whether it's centralizing data, enabling machine learning model to make decisions to improve your business process or KPIs. Once that is clear, now you enable the machine learning models and operationalize it. Operationalize it for your mainstream process and embedding that as part of your business process and existing applications. Last but not least, improving collaboration has become a necessity now, more so this year than ever before. When you enable this intelligence, centralizing data, enabling machine learning model, allowing these models not only to be interactive through the interfaces that the users are most comfortable with, whether it's a Google Sheet or a dashboard or in the form of email alerts, we enable those. Having done this many times, we have built solutions which are deployed on GCP Marketplace. where customers can download and it's pre-built 60-70%, and then they can go modify it. We will walk you through some of those examples in the following slides. When we take a step back and look at the business process that exists across manufacturing companies and expanding that into supply chain, the process more or less follows in these buckets: plan, source, make, deliver, return. You can expand that at the front and back as well to cover the full spectrum of value chain. Whether it's capturing an order, manufacturing, shipping, delivering, customers already have legacy environments or intelligence built into their systems, whether it's SAP, Oracle, or BI applications, Hadoop. They have many of these things running, but that's not good enough. The pandemic scenario, as well as this Industry 4.0, where the automation and the decentralization of manufacturing and supply chain to some extent, moving back from low cost to high cost or in hybrid scenarios, all of those are happening now. Because what was driven by labor cost is now driven less by labor cost when you convert that to automation. And now the shipping cost plays a role. So these costs now have a balancing act in determining how these manufacturing and supply chain runs. For this, centralizing your data, connecting your data, capturing data, finding insights are a key aspect. And for this, Google Cloud has all the relevant technologies that Manisha mentioned, from IoT to compute to ML to augmented reality. It's a question of how do we take some of this or all of this to enable for your business. When we look at these solutions enabled, whether it's to solve one problem or many problems, we have solved this for various customers in US, India, and many other countries. I'll walk you through some of the examples of how, whether it's a connected factory or manufacturing analytics or preventive maintenance, have saved one machine learning model has saved from 10 and have got them on a journey. And when we look at the common themes that occur when we talk about transformation, data-driven transformation, it's the same key problems that comes up again and again. Can you help improve quality of our products or our process? Can you improve the accuracy of inspection? How can a visual technology or video intelligence or vision API or any of these do better than human inspection? Or optimize my supply chain, as in there are 10,000 nodes in the network. We need to manage the supply, demand, on-time shipment, deliveries, cost, supplier rankings. It's a balancing act at every node and then collectively across all nodes. And then comes manufacturing itself, optimized manufacturing, wherein every stage at manufacturing process, is there a better way to do? If you have more intelligence, if you have more a way to capture data patterns, how can you improve our efficiencies? The last but not least, the preventive maintenance. How can you predict when the machine will go down, which makes a difference in terms of reducing downtimes, improving labor efficiencies, reducing disruptions. To do all of this, the backbone is smart analytics. And we'll define smart analytics in a minute. But first, let's take a step back and think about this. Why transform in the first place? What makes companies transform or become data-driven? It is knowing where they are in the maturity curve. It is knowing where their competitors are. It is knowing where the industry is heading. All of this having a driver, which is listed on the right, which is, as a company, you're trying to take it to the next level, whether driving productivity or you want to even build a competitive differentiating factor, like we worked with one of the automobile companies, which I'll talk about in a few minutes. Whatever your charter or drivers are, knowing where you're in this maturity curve and taking you to the next level is what Google and us as Pluto 7 help you with. And as we are doing this engagement, working with customers, trying to take them through the maturity curve, it has occurred over and over again that there are 15 odd use cases that show up again and again in this problem. This is not a comprehensive list, but gives you enough indication. When you want to optimize your business operations, like for example, you want to improve your demand forecasting, you start with that, you see the value, then you want to now optimize your supply. After that, you want to get better pricing. Then you want to see what's the demand, you want to sense the demand. So now essentially you're connecting all this information. And when you get into the manufacturing itself, what are we transforming really? What's very fundamental that's different? Why is it that Industry 4.0 is so transformational? Because we have seen technologies come in and they've improved manufacturing at various stages. The reason why 4.0 is so significant and it's once in 100 years transformation that happens is because we are challenging some very fundamental thing about us as humans. We are taking away the ability to make decisions and relying on machines to make decisions for us, either partly or wholly as a digital twin. That helps us overcome some of the biases. When do I turn the machine off? When do I feed more barley into my beer production? Or when will my brakes fail in a vehicle? And not knowing when it fails, but knowing 30, 60, 90 days before. These are things where are much better identified when you look at a data pattern or a visual inspection by an AI, which will in turn predict much better than humans. Let's go through some process walkthrough of how we do it, and I'll walk you through a whole bunch of examples for this. Like we mentioned early on, centralizing data is the key. Whether it's your legacy or existing, whether you bring part of the data or all of the data into Google Cloud or use Anthos to go across and use BigQuery Omni, there are many ways to connect your data or centralize your data. Once you centralize your data, now you can feed your data, whether it's batch or streaming, IoT, or through your legacy environments, into in various forms into BigQuery, and then you enable the automation in the form of whether it's AI models on the AI platform. We at Pluto 7, having done this many times, have built solutions which will help you visualize, plan, and automate these decisions, whether your data comes from SAP, Oracle, or even your traditional systems or CRMs. And once the decisions are created for you or recommendations are created, then you can push it back into your applications or business process, further enhancing the way you run your business. Now, if you look at the use cases and success stories, I'll walk you through a couple of them. AB InBev, they have 360 global brands, 100 plus manufacturing units. When they enabled the smart analytics manufacturing, it did not start with the grand plan. It started with solving one basic problem: when do I replace my filter? When we did that, we were able to now determine with a machine learning model to replace a filter more accurate by about, instead of 70% human accuracy based, to 90%. That saved $10 million. Once they saw the benefit of this, now there is a chain of innovation that happened all along the manufacturing process, extracting information from their MES systems, combining the OT and IT data to find insights what they couldn't find before. And when you enhance and make improvements, now you're transforming your business. Similarly, when Levi's had to pack and ship their products, basic problem: how many jeans fit in a carton? If the carton is of the inappropriate size, you're taking extra space in the FedEx truck, to your distribution center, to the receiving centers. All of this means in my manufacturing floor, I want recommendation on what is the right carton size to pick based on how the jeans is folded. We use logistics ML solutions to solve the problem. When you have a 168-year-old legacy business with global supply chain, solving such simple problems has a magnifying effect. Similarly, when you look at Southern California Edison, power plants, 300,000 plus power towers, control towers. How do you manage a wildfire situation in California when you have these power plants distributed all over the place and your assets could be potentially at risk? This is where you centralize the data through drones, collect the data through drones, helicopters, images, patrol agents, make decisions at the IoT edge, like what Manisha mentioned, make the decisions, classify the image, and create a signal. There is a potential fire hazard even before humans see it. Thinking further along, Schlumberger, they make software for oil and gas. And when they drill hole in the earth crust in the middle of an ocean 10,000 feet deep, the drill bit that runs, which hits the bottom of the ocean, has to match the conditions under the ocean, deep in the ocean. Now, we built ML models to determine the right drill bits by looking at 400 odd parameters, or features, as we call in machine learning, to determine the right combination. This not only helps with the savings in terms of getting the right, not having the drill bits fail, but anytime an oil well goes down, it's $1 million in loss every single day. Similarly, Radix, they make automation systems. There is real-time streaming data coming in from the sensors. You need a capable system, a cloud environment which can not only receive the data but process the data and drive event-based flows so that decisions can be made. Visual inspections, Hero Motors, one of the largest motorcycle manufacturers in the world, when they have 25,000 parts arriving on a daily basis, with hundreds of thousands of bins that they sort into, the accuracy is extremely important. When you bump up the accuracy from those 25,000 parts, even from 40% to more, now you're talking about reducing reverse supply chain cost by 75%, so that the wrong parts don't reach the service centers and they send it back. Predicting parts when they fail in cars. This is another scenario where you want to know when your device could potentially fail and predict those. Those are some of the innovations that we have been able to use machine learning models running on edge and on cloud to determine those. Collaboration, not just in the remote working environment for knowledge workers, but also for workers who are on the field constructing for Larsen and Toubro, wherein we use chatbots for them to mine the information, search for information, and find answers for the status of the projects. Similarly, when you do demand forecasting, and when you want to get accuracy higher than your traditional system, we were able to improve forecast accuracy for retailers. And when you look at manufacturing companies who manufacture textile goods, and during pandemic scenario, when the demand shoots up, how do you ensure that you never run out of stock on Amazon.com? That is by running machine learning models that we centralize the data in BigQuery, collect the information, and guide them to how much inventory to carry so that they never go out of stock. And for that, you're now, this is California Design Done, where they save 50% of inventory carrying cost. Similarly, when we look at what products to market to customers based on the configuration, what is already in the install base at the customer site. So we have capabilities that we have enabled for companies like Cisco, which recommends what to market based on what's available in the manufacturing floor inventory, as well as designs that match. Similarly, when you look at predictive service maintenance, your machines go down, or your automobile goes down if it's not maintained. How do you predict what could potentially go down and recommend services? That's what we did for TASPL. Similarly, when you think about forecasting demand for Synaptics, to combine internal and external data to sense the demand and forecast the demand. And when you improve the forecast accuracy by 10-20%, you are impacting the top line and bottom line. And among the last few, product segmentation, when you classify your products together and group them better than any other means of your traditional rule-based systems, now your chances of your customer finding what they want becomes higher. In essence, when you look at all these, what have we really done? We have connected the data. We have taken simple decision-making problems. We have enabled them. And when you stitch them all together, whether it's in one company or across companies, you're really transforming the manufacturing to supply chain to customer experience. And as we look at the world, the way it's evolving, it's a connected world. Your supply chain, your manufacturing, your customer experience, your returns are now starting to talk to each other. And the world expects that you have near real-time business. Google has been running their business in near real time for their own internal purpose, from search to YouTube to everything else. Now these manufacturing customers and plants are asking, why can't we adopt the same technology to make our physical world as real time as possible. And as we do that, it's a journey. First, we start with the workshop, a proof of concept, so that you understand all the various technologies and possibilities, what Manisha mentioned in her first section. And once you see the power and applicability for your own business and how easy it is, typically our workshops run for 4 to 6 weeks. Now you're ready for the deployment and transformation, and then you come to continue the journey. With that, over to you, Divya.
Thank you, Manju. So, we understood how organizations have come far with the development in the technologies. I would like to just talk a little about supply chain management as you spoke about it. I get two core ideas in that. One, that every product that reaches an end user represents a cumulative effort of multiple organizations. And two, that while supply chain have existed for a long time, most organizations have paid attention to what happens within the four walls. So you very rightly mentioned that smart analytics is the key to link both the physical and the information flow. I would move forward with the last session for today with this, which is a Q&A, and asking, I think I would start with the first question, which is for you, Manju, that what do you think were the early successes that you've seen when you were implementing these powerful technologies such as AI and smart analytics to the various customers you worked with and various organizations you worked with?
It has been an interesting journey implementing and adopting these technologies for our customers since 2016. Having heard reactions that this is sci fi or too futuristic to being eager to try and seeing results in 2016, 2017, yet change management being very difficult at that stage because you're trying to drive broader awareness. What we have seen is it's not the technology that that needs maturity because these technologies are usually proven in some industry somewhere. But you have to really fit this into the change management aspect of the business. And more often than otherwise, it is the people awareness, change management, and connecting the process that are not connected, understanding the data the process generates. That takes a lot more energy than enabling the technology itself. And this, again, it varies from industry to industry. Some industries adopt or embrace technology much faster, and they have to, and some take longer time, and the pressures are different, and the KPIs and the innovation guidelines that exist in different customers are different. So with that, I think if I were to highlight one thing is plan for change management more than what you estimate.
Yeah, I think that's really true. So you spoke about change management. With change management, could you just elaborate what role does change management play if you talk about smart manufacturing and its journey with data?
Like Manisha mentioned, some of the industries or manufacturing plants have or businesses have been over there for more than 85 years. And you have to really think and put yourself in the shoes of the employees. They have been doing their job and probably doing it really well for 10, 20, 30 years. And they did not need machine learning or AI. Now you go in and introduce that, and now you're rocking the boat, and also a well established set of process and data. You have to justify and rationalize that before you can introduce change.
Agreed. So, okay, so when we talk about all the organizations moving ahead with the enhanced transformation and everything, I would like to get this question to you, Manisha, that every organization has a different maturity curve. How can manufacturing leaders define their position in the manufacturing curve? And how do you think that this all bringing it to execution and getting it towards success, how does this happen?
Yeah, this is a great question, and I think we can break it up into two parts. So, one is how do you know where you stand on the maturity curve? Where is your position? And once you know the position, how do you take it from there, right? Where do you go from there, and how do you go from there? So, I think manufacturing as an industry, as we discussed earlier, has a long, rich history. And I think for more than a century, manufacturing companies have driven innovations such as introduction of the assembly line somewhere around 1913, mass production around World War II, and recently lean. If you look at the top 50 manufacturing companies by revenue, the average manufacturing company is more than 85 years old. And over a period of time, these companies have gone through several socio-economic events. For example, World War II ushered in the era of women in task force, mass production. 9/11 not only heightened the need for cybersecurity, but it also heightened the need for the security of the physical assets and industrial assets, right? The financial crisis of 2008 led to companies looking for low cost locations, and manufacturing companies making their supply chains global and decentralized. And now we have COVID, right? So I think while some of the changes brought by these events are temporary, history has shown that these have only accelerated the emerging trends, and they have pushed manufacturers to rethink their flexibility, agility, and speed at which they operate. So I think the companies which have survived and come out of these challenges are the ones who have adapted and reinvented their way of working. Now, the clear long history of this industry also makes it extremely difficult for the organizations to adopt the emerging trends. Decentralized decision making, multifaceted strategies, complex local politics, they have to deal with all that. There's a good news and a bad news. The bad news is that the companies have no choice but adapt to the changing demands and adopt the new ways of operating, else they will be disrupted anyway, right? So I think in terms of continuous operational excellence, many areas of the value chain have already met the peak optimization. So for each incremental improvement in optimization, the associated investment has gone up and the overall ROI has reduced, right? So in other words, over time, there have been less and less low-hanging fruits to pick, and the cost to pick is increasing. Now, the good news is you can start now, wherever you are, whenever you want, and take this journey forward. At Google Cloud, honestly, our goal is to be thoughtful of all these factors and still help our customers drive breakthrough improvements. Our objective is not only to exponentially increase the ROI of net new initiatives, but perhaps more importantly, we want to extend the value of existing investments in processes and systems that our customers have made. So maybe you can start by bringing all your siloed data in one place, like Manju mentioned, which includes your business data, data coming from machines on the factory floor, your ERP data, and any other data sources, and analyze this data to generate actionable insights around your operations. Or you can also start by just automating the quality check process and replace it with a visual inspection solution, which will lead to a better productivity and accuracy. You can also start making your supply chain smarter by introducing IoT enabled asset tracking. All these initiatives are independent and really do not require you to change your existing systems to a large extent. I think one of the underlying barriers, particularly among shop floor engineers, is the idea that the moment you connect, you lose control. So you may also want to prioritize, how much control you want to give away to automation. So I think these are some of the ways, customers and companies are looking at adopting these, emerging trends. And these are some of the ways, companies can look at going forward with these trends.
Very rightly mentioned, Manisha, about adaptation and adoption both. So I would just like to say that one thing which you mentioned was about changing to the new technologies. So change is definitely constant, and change is required to be adapted as per the technology trends. Seeing that, I would say that there is a huge potential for industrial IoT, as you mentioned in your last point, for industrial IoT in smart manufacturing. So, would you just highlight some of the challenges that we can overcome that we face while integrating this IoT IT for the real-time insights?
Absolutely. And I think it goes back to the same point of this being an old industry with a long history, siloed operational technology systems, which sort of limit digital transformation, right? So I think, therefore, it's even more critical for the customers and manufacturing companies today that when these companies are looking at modernization or standardization initiatives, They adopt a platform which is open and works seamlessly across systems and workloads. So there are really three aspects to this problem statement. Number one, how do you bring the siloed data from disparate systems together? Number two, how do you manage your solutions and applications across an hybrid multi-cloud deployment model? And lastly, how do you derive actionable insights from the analytics and how do you democratize it, across your organization? So I think, like I covered in my part of the session, the first problem statement of bringing siloed data from disparate systems, we have solutions for smart factory, right, which is really a combination of three components: an edge solution, which is a hardware module embedding our market leading edge tensor processing unit, and a software solution manager that can deploy your AI and ML models on the edge devices, bringing analytics to data rather than bringing data to analytics. Number two is IoT Core, which is the hardware agnostic platform for ingesting data from these edge devices and managing these devices over a period of time remotely without really having to, having a high touch engagement with those devices. And number three is the entire data analytics, AI, and ML platform, which we can use to analyze this data and then generate those actionable insights out of it. I think the second problem statement that we talked about is how do we manage your solutions applications across hybrid multi-cloud deployment models, which is very critical because you as a CIO or CTO of a manufacturing company don't want to always worry about managing the infrastructure underlying your applications and solutions and would rather want to focus on building new applications which can have an impact on the top line or the bottom line of your business. So Google's Anthos platform is one such solution, which is a 100% software-based hybrid multi-cloud offering with which you can build your application once and deploy them anywhere. So one of the customers who has done this with us is Kyocera in Germany, who have used Anthos as a multi-cloud platform and our data analytics, capabilities to stream the real-time data from the compressed air stations to Kyocera's central IT systems. They have established a mesh of solutions which are able to run across different cloud environments, both on-premise, edge devices, and on different clouds. And they have empowered use cases like predictive maintenance, analytics, and monitoring of new software. So I think it's all about, bringing data from your factory floor, your edge devices, from your business data, from your ERP modules, and then creating those actionable insights, which can then be democratized and made available to the entire organization, which actually needs a lot of cultural and operational changes within the manufacturer's organization as well.
Thank you, Manisha. Thank you. That was indeed insightful. So, moving forward with the last question for this session, I would like to request Manju to please throw some light on how can there be a starting point to work with Pluto 7, as there are many apprehensions that organizations sometimes face with managing their data and everything. So, would you just let us know how that starting point can be, wherein they can start working with Pluto 7 and get their problem solved?
Having worked with hundreds of customers, we have come to realization that customers are going to be at different stages, and not only in terms of their maturity and evolution or their own plans of evolution, but also the awareness of cloud or cloud readiness. Irrespective of what stage you are, what is more important is where do you want to be? And even if you need a help in us helping you articulate where you want to be relative to your competition or relative to what's happening in the industry, we can sit with you, conduct a workshop, and get to the bottom of it. And then, based on your ecosystem, your data, your systems, your process, we can suggest to you what's the possible path. And while doing that, we bring in the best practices from Google. Not only what has been done by us as a partner, but has Google solved this problem better than anybody else? Or even you might find some golden insights from Google themselves, right? As in they run their data centers saving 40% of energy savings just by running your key machine learning models. Our engineering relationship with Google and Office of CTO and some of those, we'll bring in whatever it takes to solve your problem. So the key is start the journey. Rest of it, we'll find our way together.
That was amazing, Manju. So I think with this, we come towards the end of our session. I would like to thank both my speakers. Thank you, Manisha. Thank you, Manju, for this rich download around analytics and smart manufacturing. This was indeed an amazing session we had, and we look forward to having many more such insightful sessions in future. Thank you.
Thank you, Manisha.
Thank you, Manju. Thanks, Divya. Bye.
Thank you, Divya.
Thank you.